Grand Canyon-Parashant National Monument is a vast and rugged landscape. Mountains and plateaus stretch far into the distance. These viewscapes are an essential feature of the remoteness that defines Parashant. The monument preserves a vestige of the West prior to American settlement, free from intensive development. However, these views may be under threat. Urban centers in the desert Southwest are rapidly expanding. In fact, one of Parashant's nearest neighbors, St. George, Utah, is currently the fastest growing city in America. Will this increased activity create more air pollution and haze? Are the bright lights of the Las Vegas Strip far enough away to preserve dark nights? Meet physical scientist Eathan McIntyre. Eathan is installing a system of monitoring stations of his own design to collect data on air quality and light pollution. He wants to know how these changes could affect both visitors and wildlife.
I developed this system of time-lapse imaging cameras that actually look across the landscape, and we're trying to create metrics. One of the aspects of air quality is transparency. It's just how clear is the air, and what does that mean to the visitor? How far can they see? These aren't just roadside stations. A lot of these sites have to be remote locations as far as getting the view shots that we want to get. A typical station involves a tripod, solar panel, and of course the camera assembly. These cameras are time-lapse cameras taking an image about once every minute. What's really cool about this project is that not only am I just getting time-lapse, but I can develop meaningful metrics, as in how many miles can you see across the horizon. Our setup here is about 110 watts. It's about enough to charge a cell phone, laptop, but we got plenty of power up here to run our station, get our cameras up and running. Just check over some of the scripts here, make sure they're all where I need them to be as far as waking up and shutting down. We'll be leaving the station here for about 6 months, coming back in the spring. Up 2 cameras at 2 different locations looking at the same target, and what we're able to do is generate pixel values. Basically, we're looking at the mountains here along with the sky above us. Are they brighter, darker over time? And what we're able to do from there is create a ratio. We're seeing the camera and the pixel values, and so we actually put those values into our equation, and from there we actually generate how visible the actual air is. So we get some great numbers off this. So as you can see right here, we go ahead and put the numbers into our equation. For example, here on a really good day, we see 35 miles of clear air. That's one of our best days. On our poor days, we're seeing fire events. Here we see only maybe 3 to 5 miles of visibility. That's when we just see all sorts of smoke from wildfires come into our west half of the monument, and it really obscures our view. We also pick up, artificial sources such as from road surfaces, people out there in long convoys kicking up dust. So this is really meaningful. We're not just generating just great time-lapse images, we're seeing some really meaningful metrics as far as how clear the air is and what does that mean to the visitor experience. One of the trends we're thinking about is what is going on with as urban centers expand around the monument. How much smoke is just coming from just common urban center use, such as fireplaces and just automobiles, And so we're actually looking for seeing if there's any long-term trend as far as are we seeing any escalating levels of smoke and dust. So these cameras are able to pick up those trends.
Development and city lights threaten dark night skies as well. Eathan stations are equipped to monitor the night sky over Parashant and sky glow from neighboring metropolitan areas.
This night sky camera is actually special for astronomy. It has a very sensitive CMOS sensor in it. We program it so that it basically stays open for 45 seconds. And we're able to capture all the natural light from Milky Way, constellation stars. Parashant dark skies are actually a remnant of what we see from the Wild West. Basically, no development. And that's what's really cool about Parashant, is that we have very little development as far as structures and light bulbs. However, what we see, even from about 95 miles away, we're still picking up the sky glow from Las Vegas and Mesquite, St. George, Utah. A lot of our wildlife we see out here is nocturnal. You gotta remember, these are arid landscapes, desert environments. So a lot of the wildlife activity occurs after sunset. And these animals rely on dark skies and the pattern of the moon going across the landscape. And so what happens when we see here, we get this artificial sky glow, we see that it creates sort of a second moon effect. These animals are getting confused, and it's going to change their behavior.
Desert wildlife, like humans, are synced to cycles of day and night, each in their own way. Nearly 50 species of birds on the monument migrate at night. They navigate by the stars and become disoriented by bright artificial lights. Kangaroo rats forage less under the full moon to avoid predators. A nearby city mimicking the light of the full moon prevents the rat from being able to eat enough to reproduce.
Are these landscapes getting lighter or darker? Are the urban centers giving us impacts? It's really meaningful to be able to tell what our neighbors are doing out there.
For more information on dark skies and light pollution, visit the International Dark Sky Association at darksky.org. Grand Canyon-Parashant National Monument is an international dark sky monument.